from yesterday. Number 8, 100 annual fee and $5 fee for each class. So this one is a little confusing because you have the word annual here. I would just cross out this annual word and say that there's a $100 fee with a $5 fee for each class. When you see that each class, you know that the 5 is your M and the 100 is your B. So your equation, y equals 5x plus 100. For number 9, you want to find the equation for the cost of printing. So $2.50 per calendar, and with a 500 cost to start up the printer. So 250x plus 500. Okay. And then number 10, you're asked for the income. So some people were asking about this question. What's your equation for number 10? Felicia? Oh, that was number 9. Number 10? Y equals 5x. Simple as that, because it doesn't cost you anything to get money. Okay, so if people buy a calendar, it's $5. Okay, there's no plus or minus anything, so you just leave it like that. So for number 11, notice it was asking you for the total cost. So I'm gonna use this equation from number 9 to sub in 200. And so to make 200 calendars, it's going to cost me $1,000. Right? Similarly, if I can sell 200, if I can sell all 200s of it, I use this equation to figure out my income. $5 per calendar, 200 calendar, that's 1,000. So for number 13, who has the answer for number 13? What can you conclude? Do you make money, lose money? Maria? Right. There's no profit or loss because both equals 1,000. So to make money, how many do you have to sell? To make any sort of money with the calendars? 201. So anything more than 200, you make money. Anything less than 200, that means you're going to lose. All right. George, help me with number 14. Yes. All right. And then number 15, Babak? Y equals 0.75 times 18 to 3.00. Yep, good. And so then that means for a taxi ride that's 18 miles far, it's going to cost you $16.50 in the taxi. Jaden?
For question 13, what do you put?
Oh, I put no profit or loss. And to make a profit, you have to sell more than 200.
So for 11 and 12, if you change both of them to 201, would it make a profit? You added one to.
Oh, good question. If you put 201 here and 201 here, it's gonna be one to make it. It's gonna cost you $1,002.50, and your profit will be $1,005. So then, starting the 201, you make $2.50 profit. Yeah. Yep.
Number 16 was a bit confusing for me. So was it H equals 30,000 subtracted by 2,000 T?
Good. Yes. So for this one, I told my morning class I don't want to just use X and Y. I wanted to use any other variables. So they said F for feet and M for minute. Okay. I like yours. You use H for height and T for time. Okay. I like that even more. So the key right here is that it's negative 2,000. Why negative? Which part in the question tells you that you should put a negative there? Austin? Descending, that's right. So if it's positive, it means that your airplane is going into space. It's going up, 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 up. You're trying to descend your plane, so that's why it's negative here. It doesn't matter if you put the 30,000 first or this first, as long as it's negative 2,000 M or 2,000 T or 2,000 K, okay? And so after 5 minutes, that means the plane is at a height of 20,000 feet. Okay, so I think we're pretty good with building equations. Let's take out the last three on the correlation coefficient. This one right here, after you graph it, most of the points are on the line. So it was pretty strong, and so it is close to 1. Remember, if it's all on the line, that means R equals 1. If it's almost all of it, then it's pretty strong, so it's close to 1. Okay. Number 8, don't worry about calculating the correlation coefficient, because to calculate it, you do that in like grade 11 and 12. All right, so for now, we're only using words like strong, weak, positive, negative, these descriptive words to describe the correlation. So just thinking in general, do you think there's a relationship between your math mark and your physics mark? Is there a relationship between your math mark and your physics mark?
Oh, I'd say yes, because all physics requires math.
Yeah, yes. Usually, if people do really well in math, they do really well in physics. If they don't do well in math, they don't do well in physics as well. Okay, so I would say that when you graph this and you plot that line of best fit, it should suggest a strong positive correlation. And an example of a number then, a number to represent a strong positive correlation. What number would you use to represent a strong positive correlation? Armin? Or 0.9, yeah. R equals 0.9 or 0.95. Anything more than 0.75, I would say is strong. Right, Harry? Mm-hmm. Do you need to sit back at your own desk? Can you pay attention then? Where you are? Okay. Okay, and then this one, number 9. Calories per hot dog and sodium per hot dog. So Harry, do you think there's a relation between the calories in hot dog and the amount of sodium in them? Yes. So and that's what you would say. When you plot these, you would always write it as x increases, what happens to the y? Right? And so in this case, you would say as calories. This is your x, right? So as calorie increase, sodium increase. Right? So whenever it asks you about the trend or the context of the problem, that's what you want to set up. This is like the outline of the like it's almost like fill in the blank. So as your x value increase, what happens to your y value? So as calorie, which is your x, increase, sodium also increase. Okay. For some of these, you don't even need math. It's just common sense, what you think. Yeah, Jaden?
Shouldn't it be the opposite or calories is y because it depends on like how many milligrams of sodium you're on. Or you could say both.
Yeah. Yeah, and this one it's interchangeable. Just like the other assignment that we did the other day, like your shoe size and your height. You could say the taller you are, the bigger your shoe size, or you could say the bigger your shoe size, the taller you are. It's the same as long as you say both in your sentence and you can explain the relation. That's fine.
So if you have like some hot dogs and selling like drinks, let's say like it can be both. It's both. It's both much.
Yeah. Just like the other one that we did yesterday, popcorn and soda. Yeah. Right. Okay, so that was the homework yesterday. How many of you got most of them correct? Okay. So today, very important lesson. So you know how a few days ago I said smoke was the most important lesson? No, I didn't lie. Did I lie to you? You already did that? Nice. Oh, okay, good. So you're ahead. Did you do it correctly though? Yeah. Okay. So we'll do it together. Okay, so 3 days ago I said slope was the most important lesson in the whole course. Graphing lines is the second most important lesson in the whole course. So today's lesson. So make sure you're paying attention. If you don't know how to graph lines, you won't be able to survive for that.
Oh yeah,
Thank you.
I'll say that.
So that's why you should pay attention to that. One, two, three, go. Okay, so let's make sure we know how to graph lines. Everybody got a copy? Good. Okay, so make sure you pay attention. Those Chromebooks, put it away. Cell phones, put it away. Close. Okay. Logan, you're not distracted? Okay, good. What about you, Dante? Are you distracted? You look distracted. It's distracting me. Let's put it away. Put that phone away. Okay. So, yesterday we know how to make our equations. So now let's learn how to graph it. Okay. So given this equation right here, what's my slope? What's my y-intercept? Logan.
And it's 3 over 4 x.
Ah, just 3 over 4, no x.
1.
Good. Okay. So now this is how you would graph it. Bianca, are you distracted? Are you distracted? No? Okay. Okay, so we would always graph our y-intercept first. We would always plot this y-intercept. So y-intercept, what does y-intercept mean? It means the point on my y-axis. So I'm going to plot 1 on my y-axis. Where's 1 on here? Okay, there's my first point. And then from this point, I'm going to do my slope of 3 over 4. We did tons of this, right? So how do I get to the second point? Go up 3. 1, 2, 3. Just hold it there and then go over 4. 1, 2, 3, 4. After you do your rise and your run, that's when you put the second point. All right, so make sure you don't just put that point up here. It's not a point until you do both rise and run. And there you go. You have your line. Okay. What's wrong with this line? Yep.
Coordinates on the equation.
I don't need that, but King, you said too short, right? Your line doesn't stop there. A line goes on forever, so make it nice and long. Okay. And so this is A. Okay. Yeah.
But we're not doing an exponential equation, so we can already find a slope from 2 points.
We're only doing linears.
Yeah, so we only need 2 points.
Yep. So for B right here, y equals negative 2 over 3x plus 6. Okay, what's my slope? Yep, negative 2 over 3 is my slope. And my y-intercept? 6. Okay, what number do I plot first? The 6, right? So on my y-axis, I'm going to plot 6. That's my first point. Okay. And then now I'm going to do my slope of negative 2 over 3. So what do I do from this point? Yeah. Go down 2 and then 1, 2, 3. And there we go. That's my second point. Once I have 2 points, I can graph my line. Okay, make it nice and long with the arrows on the end. So that's B. Okay. C. What's my slope? What's my y-intercept? Maria?
It's 2, and then your B is negative 7.
Good. Okay. Plot that negative 7. So plot the negative 7 on my y. So which is right here. And then a slope of 2. What does that mean? What do I do from this point? Okay. Go up 2. And then over 1. That's right. Because 2 is the same as 2 over 1. You always have a rise and a run. So here, even though it says m is 2, this is the same as 2 over 1. So up to over 1. Okay, so there's my line. Okay, like that. Okay, and there's, that's C. Okay. D, negative 3x plus 5. Yeah. Maybe you want to try this? Negative 3 over 1. Awesome. And what's my y-intercept? 5. Yeah. Which do I plot first? Which number do I? The 5. Awesome. Good job. So put that 5 there on my y. And from this point, I'm gonna go down 3. 1, 2, 3, and over 1. Okay. Okay, and this is D. E. Okay, this is a little tricky. E, what's my slope? What's my y-intercept? Logan.
So the slope is 4 over 5.
Good.
And y-intercept is 0.
Good. All right. If there's nothing, it means your y-intercept is 0. Right? So 0 on my y-axis, it's right here, right on the origin. And then from that point, I'm going to do my slope, which is 4 over 5. So up 4, 1, 2, 3, 4, and over 5. 1, 2, 3, 4, 5. And there's my second point. Okay, there we go. And this is line E. Okay. Can you guys try F and G? The last two? Try F and G. Yep. Try to graph F and G. Okay, so for F right here, what's your slope? Yeah, George? Yeah. And your y-intercept? Good. So then I look for negative 6 on here. Negative 6 on my y-axis is right here. Right? And then from this point, what am I going to do? George?
You're going to go down 1.
Yep.
The right 2.
1, 2. Perfect. Okay. Now let's notice these 2 points are really close together. And if I were to extend it, it might not be so accurate. So how do I make my line more accurate? What can I do? Jaden? So if I want to make my line more accurate, I want more points on this line. What can I do? Extending is, can I make it more accurate? Just repeat the slope. Down 1 over 2. Down 1 over 2. Down 1 over 2. So I could keep going with my slope to make it more accurate. Okay, and this is line F.
There's the first expression.
Yeah.
Wait, when you draw the line, does it have to pass through the y-index?
No.
No.
No. As long as you make it like a little longer, then it's all good. Okay, last one. Y equals 2x minus 5. What's my slope, DeAndre? Yep. And my y-intercept? Good. So what do? Yeah, plot a point on negative 5. Yeah, I go up by 2 and then? Over how many? 1. Yeah. Why do you go over 1? All right, any whole number, we can always put that number over 1 so that we can see our rise and our run. So 2 is the same as 2 over 1. So that's why we did that. Again, if I want to make my line more accurate, I could go up 2 again, over 1, up 2, over 1, up 2, over 1. And there we go. That's G. Okay, how many of you got these two lines? Awesome, the whole class got it. So we can move on to graphing inequalities. Okay, so I'm just doing 3 examples and then I'm done. Okay, so take a look at this equation and this equation. What do you see different? What's different between these two equations? Bigger than, right? This is an equal sign, and so it's just a line. This one, though, it's a greater or equal to sign, and so instead of just a line, we also have to shade it in. Okay? So for example here, you would graph it the same way, exact same way how we did the last 10 graphs. Where's my pen? So here, you plot that 4, and then -3, so you go down 3 over 1. There's my second point. I graph that line, but because it says y is greater than anything above the sign, then I shade in the top part. So it's everything above it. Okay? Everything above the line. Okay? So let's try with this one then. There's my pen. Okay, so for this one, what's M and what's B? Don't say.
M is 3 over 5.
Yep, 3 over 5. And B is
-5.
good. Okay, so I'm going to first plot.
You're going to put the -5 on the y.
Perfect. Right here. And then from there, I'm going to do my slope, which is rise 3. So 1, 2, 3. And then go over to the right 5. 1, 2, 3, 4, 5. Okay. And I draw my line. Okay. Now, because y is less than this line, do you think I should shade in the top part or the bottom part? Bottom, because it's less than. So less than means I shade in the bottom part so that it's everything less than my line. Okay. Yeah, that's it. Yeah, you just shade in. You don't even need these arrows. I just wanted to show you that y greater than is more above, less than is below. Yeah. That's all it is. All right, let's try number 4, my last example. What's M and what's B right here? Maria, what's M? All right, Maria says 1. Logan says nothing. What's the number for nothing? 0. Right, because there's no x. So it's like 0x. And my y-intercept? -4. Okay, good. So I'm going to plot -4 on my y. And for a slope of 0, we did it for like 1,000 times. Slope of 0 means it's a horizontal line. That's right. Now, but, before you draw that line, I hope you're not using pen. What's the difference between this symbol and this symbol? Yeah.
One is greater than or equal to, and one is greater.
Yeah. So if it's greater or equal to, we do a solid line. For just greater, what do you think we do? Dotted line. That's right. Sure. So the difference between this equation and this equation, Notice this is greater or equal to, and this is just greater than. So if it's greater or equal to, we do a solid line. But if it's just greater, then we do a dotted line. Okay, should we shade it above or below? Who says shade above? Who says shade below? All right, y is greater than, so above. Shade it above the line. Okay, so I think you guys are really good with graphing lines now. And this is the second most important lesson in the whole course. So if you got it, awesome. If you didn't get it, here's some practice time for you. So try these ones right here where you're graphing inequalities. And then here, these are step-by-step investigation of how the line will change. Okay, so try these out. You have plenty of time right now. Tomorrow after your assignment, we're gonna take these up. Okay, so make sure you complete all of it. It's not long, it's just this. Okay, so the front side and the back side. All right.